Hello all. This video is a continuation of the previous one and it's nothing but Industrial Internet of Things. So in the last video we learned about the types of sensors, classification of sensors as active sensor, passive sensor, and the vector sensor and the scalar sensors. So it's like this one is nothing but the scalar sensor. It usually detects the input parameter only based on its magnitude. So when the sensor can sense only the data magnitude, then we say it as a scalar sensor. The response of the sensor is a function of magnitude of the input parameter, not affected by the direction of the input parameter. For example, the temperature sensor, gas sensor, strain sensor, color sensor, or the smoke sensor. So, say for example, if there is a temperature sensor, it indicates the temperature is 98.4 degree, 100 degree, that's all. But it cannot indicate the direction. Likewise, gas sensor, yes, the presence of gas, CH4, the presence of gas, CO. So strain sensors, color sensors, and the smoke sensors just indicate that the presence of the signal. Yes or no. It's like the binary data. They will not indicate the direction. So because of that reason, we say these sensors as scalar sensors. So the next type is the vector sensor. The response of the sensors depends on the magnitude of the direction and orientation of the input parameter. Say for example, if we are using a magnetic compass, say for example, if I want a direction and if I want how many kilometers I walked and came from my house, from my home, say in which direction, then it is called as a vector sensor. If the device can produce an output like that, then it comes under a vector sensor where I'm getting the distance, where I'm getting the direction in which I walked and came from my home. So accelerometer, gyroscope, magnetic field, magnetic compass obviously, and the motion detector sensors. So these types of detectors or the sensors are called as vector sensors, where it will be producing the magnitude, uh, the data, the number, along with the direction or the orientation of the input. So the next one is actuators. Actuators are like fuels mainly, which makes the system to move. In human bodies, like we have legs and hands for movement, for locomotion, and especially in the arms and also in the legs, we have joints for the inner movement. So these movements are possible because of the joints. Likewise, for robots, only the presence of actuators or the motors, the robots can move or the system can move. So the simple block diagram for an actuator is nothing but energy actuator, which is uh, which will be given with a signal, which will be then given to the motion or the force. So an actuator is part of the system that deals with the control action required, mechanical action, mechanical or electromechanical devices. Actuators are nothing but mechanical or electromechanical devices. Actuator, a control signal, as I told already, the picture of the DC motor is mentioned here. A relay is also mentioned here. Both are nothing but the solenoid. Solenoid is also mentioned here. Both are nothing but the actuators. A control signal is input to an actuator and an energy source is necessary for its operation, available in both micro and macro scales. So when the movement is little, we can go for micro scales. When I want little bit fast movement, then I can go with macro scale movement. Say for example, the electric motor solenoids, the hard drives, stepper motors, comb drives, hydraulic cylinders, piezoelectric actuators, and pneumatic actuators. So, actuator is nothing but a device which facilitates the movement or locomotion of one device. So, electric motor uses electrical signals. Stepper motor will be used for producing step-by-step movement of the system. Hydraulic cylinders are used in very high applications. Hard drive stepper motors can be used. Solenoids can be used with on-off application. Move one step forward, off. Move one step forward, off. Stepper motor can be used for step-step movement. And hydraulic motors can be used in very heavy applications. Pneumatic motors or pneumatic actuators can also be used in very high applications. Pneumatic actuators are and the hydraulic actuators are quite costly and expensive to maintain. I hope you would have learned from this video. See you in the next video. Until then, it's bye from Radhika.